2. I'm going to start with the one on the left here. So again, there's only one way we can be at A, and branching outwards from A, like a triangle, there's only one way we can get to each of these points. Now you'll notice that this one looks a little bit different because the rectangles have these kind of blank spaces in between them, so it ends up looking like big huge rectangles and holes in between. Sorry, we're just filling a thing with water. Hope you enjoyed that sound. Okay, so continuing on, we'll just do the question exactly the same way as we were doing all of the other ones, but we'll just be careful because of these holes and gaps. So 1 and 1 make 2. This intersection is made by adding 2 and 1. Now if we look at this point right here, normally you might think, oh, this should be 3 because 1 and 2 make 3, but you'll notice that since it doesn't connect, it's like 1 and nothing. So this is only 1. This one, though, is made from 1 and 3, so we have 4. So you must work very carefully with these gaps. 2 and 4 is 6. This one right here is a branching out one, so it doesn't change, or you can think about it as 3 from the left, nothing from the right. And this will give us 7, 13, 13 from the right, nothing from the left. This is 7 from the left, nothing from the right, same as this one. Here we'll have 13 plus 7, so that's 20. 27, 33, 33, and grand total of 60. We can also do the same thing with checkers. The point in checkers is to get a piece from one end of the board to the other. So for this question, it might be, in words, might say, how many different ways are there for this checker piece to end up on the other side of the board? So we want it somewhere in this line. So first we'll figure out all the different ways, and then I'll show you how to add them up. So checkers cannot move backwards. They can only move to the side and forward. So we end up with our 1, 1, 1, 1, 1 triangle branching out like this. Can't go to the side. And then it must also stay on its color. So if this is on the black, then we're only looking at the black squares. So 1 and 1 make 2, 1 and 2 make 3, 3, 4, 5, 6, 6, 10, 15. This guy is going to be 3 plus nothing. This will be 9, 19. This will be 9 plus nothing. This one here will be 6 plus nothing. Oopsies, 6. This will be 21, 34, and 28. So there are 6 different ways the checker can end up here, 21 different paths it can take to end up here, 34 here, and 28 here. So the total number of paths that it can take will be 6 and 21 and 34 and 28. That gives us 89. So 89 different ways that the checker can end up across the board. Now let's go back and try that Plinko example. So I don't know if you guys ever used to watch The Price is Right, but this game is like the game Plinko. So I'm going to draw in the grid because it might be a little bit tricky for you guys to see still. Oh my goodness, I should use a ruler. Okay, extend this out a bit. So I'm going to use a different color for this one. Okay, so we drop the piece in, and it's kind of like pinball. So the little piece that you would drop in here could fall between all of these pegs, and depending on where it ended up at the bottom, you might win a different sum of money. So when you drop it in, there's only one way it can end up here, and obviously since you're dropping this down, there's no way it's going to move backwards. They're always moving down in this case. So here are all of our ones. 1, 1, 1, and then we can start adding up. 1 and 1 is 2, 3, 4, 3, 6, and 4. So if you were making up this game and you were going to put let's say like a $1,000 prize and a $5,000 prize and a $10,000 prize, clearly since there are 6 different paths that the chip can take to end up in this spot right here and falling down, you might want to put the cheapest prize here, so maybe like $1,000. And then here, maybe $5,000, because there are 4 ways that it can end up here. And then here we might put the $10,000 prize, because there's only one way that it can end up going all the way down here. So that's how we work with the Plinko example. Let's go to the second page now. So you'll notice with numbers 1 and 2 that these are distinct rectangles. So I wouldn't actually do these ones by adding up all the individual paths. I would do them as permutations. So in this case, if there are 1, 2, 3, 4, 5, 6, 7 times we have to go east, so there's 7 repeating easts, and 3 ways to go south, so there's 10 blocks we must travel altogether. I would just do it like this, and you end up with 120. For number 2, for the first one we have 4 repeating east, 3 repeating south, so there's 7 blocks we must go all together. So that's for this first rectangle. Now we need to multiply by all the possibilities of our second rectangle. So we must go 6 blocks where we have 3 repeating east and 3 repeating south. If you evaluate this, you should get 700. Now for 3, 4, and 5, what I'm going to do is just give you the answer, and you can check on your own to see if you can get that answer. If not, we'll go over them tomorrow. So 220 and 57, and then number 5 I'll give you as well, and I'll do the scariest looking one for you. I'll do 6. Oh, that's 82, not 821. It's Journal's fault. Okay, let's do number 6. So starting at A and branching out, we've got our 1s. So 1 and 1 make 2, 1 and 2 make 3. Here 2 and nothing give us 2. 2 and 1, 3. 3 and 1 is 4. And 1 and 5 is 6. 5 and 3 is 8. 8 and 4 is 12. And branching out this way, 6 and 6, because there's nothing coming from the left. Branching out this way, 12 and 12, since nothing is coming from the right. Now this point right here is attached to the 6 as well as 8, so this is 14. This point right here will be 12. So this right here is 14 plus 12, which is 26. This right here will be 26 and nothing. And this down here will be 26 and 6, which is 32. Out along this way, there's nothing coming from the right, so these will just be 12 and 12. And this guy, 24. 38. 30 and 12 is 50. And 24 is 74. 24 and 12 is 36. 36 and 74 is 110. 26 and 50 is 76. Plus 32 is 108. 108. This is 76 from the left, nothing from the right. It's not connected, so this is 76 still. This will be 76 plus 110, so 186. This will be 108 plus 76, so 184. And so the total number of paths we can take from A to B will be the sum of 184 and 186. which is 370. So there's the scariest one done for you. Hopefully you can get numbers 5, 4, and 3 on your own, and I'll see you tomorrow.